This number of solutions heading is just kind of giving you an introductory problem where you have 1, 2, 3, 4 lines all plotted on the same graph. So this would be like a system of 4 different equations, and then as we look at these 1, 2, 3, and 4 separate problems, the idea is for these two specific lines, we could treat this like one system of equations. Is there no solution, one solution, or infinitely many solutions? Now in geometry, often you get these kind of complex diagrams. I don't think that this is too crazy, but well, you should have a pencil out, really. So instead of like using your pencil and writing hard, write lightly so that you can shade this or erase this easily. And so with that pencil, find this first line, y equals negative x plus 5. And since it's clearly tagged, you can just take that pencil and lightly trace it, so that it'll draw your attention just to that guy. Now let's say that you had to graph this. You would have been able to say, well, the y-intercept's at 5, and it's going to go down 1 over 1 because of its slope. So if I got that tagged, I'm going to look at the y equals x minus 3, and then lightly with my pencil, I'm going to trace to y equals x minus 3. And since all we're asked to do for number 1 here is say whether it has no solution, one solution, or infinite, this only has one solution. Now I abbreviated SOLN in the notes because I didn't have much space, but there I'm writing it out. Now because we wrote this lightly, my hope is you can erase it pretty easily, and in moving on to the second one, draw your attention to that same first line again, but then see if you can find this guy. If we had to graph 2x plus 2y equals negative 8, we'd have to either use the x and y intercepts or solve it for y. But because they've tagged these, all I have to do is find this, and I see that it's clearly running into this guy. And we probably wouldn't always assume that these are parallel, but to me this looks like a safe bet that these are parallel, because just like this one going down 1 over 1, this one goes down 1 over 1 too. And since we know that they never run into each other, we would know that this would be no solution. I personally think that that makes sense. I'm not flipping back to the previous page to where I can find out whether or not it agrees with my little chart. 3 and 4, make those on your own problems. In 5 seconds, I'm going to put the answers up. Three, infinitely many solutions because they share the same line. 4, one solution. And they never ask us to compare these two lines, but if they did, I think you can safely see that they would eventually run into each other. Here you're not given the graph. Here you have to graph it yourself. So you can see how if I'm solving systems of equations by graphing, suddenly it's pretty darn important that you graph neatly so that you can see where they actually do run into each other. And most of the time they'll give you problems that lend themselves nicely to that. But if you're doing book work and then having to write this in your own spiral, you're going to want to keep it pretty darn neat. By the end of the section, you'll have all ways to check it. Now, if this was book work, I would rewrite this in my spiral. And if I had printouts of graphing paper, I would rewrite it alongside of it so I could clearly see it and not have to jump back and forth. So if I have negative x plus 8, we always start with the y-intercept. So here I am beginning at 8. So you got two choices here. You can either treat this as increments of 2, because you'll notice that this graph only goes up to 7. So if it goes up to 7, I'm just going to treat this positive 8 like it's right there. I don't think that's getting so far away to where it's going to mess me up. And then I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. And you're definitely getting your ruler out for this. And needing to be neater than I am, because as we graph these, you don't want to be approximate, you want to be exact. And we can even label this as y equals negative x plus 8, so that we know which line we just wrote down. For the other one, we have 4x minus 7, which I'll graph in a different color. So here's negative 7 where the y-intercept would be, up 4 over 1, up 4 over 1, up 4 over 1. Now notice that I didn't stop when I had just 2 points. It was important to me to graph it all the way until I had a point where it ran into it, the other line. Again, taking a ruler, being neat, and I can label this as 4x minus 7. And because I graphed this neatly, I can clearly see that my solution would be at 3, 5, as I just count. And since this work needs to be made clear, both of these lines have an infinite number of x's and y's, but they only have one specific x, y where they run into each other. So when we summarize our answer, we're going to say that a coordinate, x, y, is equal to 3, 5, and box it and clearly show where that's at. I'm erasing that label only so that I can move on to the next line. Now the predicament here with the next one is we don't have this set up in y-intercept form. So you could do this either of two ways. You could find x and y intercepts since they're in standard form, or you could solve each one for y. I think just so that we can get some review, I'll do it both ways. So for this very first one, I'm going to write x plus 2y equals 5. And when a teacher gives you worksheets and things, he's not going to give you a ton of extra pages. So you have to try to sneak this in and keep it neat. And then when I divide both sides by 2, now I can clearly see that I have a slope of negative 1/2 x and a y-intercept of 5/2. So when I start with my y-intercept of 5/2, I'm right here in the middle between 2 and 3. And now I'm going to go down 1 over 2, down 1 over 2, and hopefully you can see that that means you'd be hitting the whole numbers here. And again, doing my best to graph it as neat as possible. And just like before, labeling it x plus 2y equals 5 since that's the original equation that they gave us. So that was me solving for the y, so they would be in slope-intercept form. So hopefully that's good review. Your other choice is to figure out what the x-intercept and y-intercept is. And your x and y-intercept, this is where y is 0, and this is where x is 0. So if I picture y being 0, 2 times some number gives me 2, which means that my x-intercept is 1, 0. For the other guy, it means that 0 would be x, so 4y has to be 2, which means that y would be 1/2. You're not sure where that's coming from. Watch it again or come see me, but I'm treating it like it's a review because it's from the past. So now for this new line, we have two values. Here's 1, 0, and then I also have 0, 1/2. And when I go to graph this line, they seem to be parallel. And so if this was a odd number problem, you'd look in the back of the book just to make sure you were confident that they were parallel, and you'd write no solution. Since that's not always an option, you could also turn to a friend and see what they got, or you could go ahead and solve this for y anyway to see if you had the same slope. Because if you had the same slope, you'd remember that that means you have parallel lines. Having graphed two of them, let's make these both OYO problems. And since they're OYO problems, you can do it either of two ways that you'd like. I think this lends itself pretty nicely to finding the x and y intercepts, while this lends itself to a mix. You know, here you just jump right in, and then on this one I think it would probably be best to solve y equals. But like I said, I'm going to just put my work up for both of these in 5 seconds. And so check to make sure your graphs are neat. This came out real nicely for me. This first line did, and then once I rewrote it, You can see that it has the exact same slopes and y-intercepts. So the original equations ended up being the same line. And since the instructions do say to name it when you have one solution, we would write x comma y equals 3, 1, and then for the other problem, infinite solutions. And to be thorough, here I am plugging in this coordinate, not just a 1, because it could be accurate in the first, it could be accurate in the second, but to be the correct answer, it would have to be accurate in both of them. So here I am just seeing 3 minus 1 becoming 2, so we're good there. And then here I am doing 2 times 3, kind of strange because it's not the first thing. They wrote it in a different order. 2 times 3 being 6, plus 3 times 1 being 3, and 3 and 6 giving me 9.